Hi everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is string compression 2 and it is a hard level problem. So this problem even took me some while to solve, and I was actually missing some of the DP states, that is why I couldn't solve the problem earlier, and later I realized what are all the DP states that we need to consider, right? So this particular problem says that we have been given a string and they have defined run length encoding as a string compression method. So what this algorithm says is, let's say you have multiple characters. So we'll just take this example, AAA, AAA, B, C, C, C and D, right? So what we generally do is we count the number of A's that are together and we write A 3 because there are 3 A's here. Then we count the number of B's, we write B. We only write this frequency when the frequency is greater than 1, right? Since B is equals to 1, then I'm not going to write B1, right? It is only going to be B. Then I have C multiple times, so I write C and then I write 3, right? Now I have D. So this is how this compression algorithm works. Basically, you take all the consecutive similar characters and append its frequency after it only if the frequency is greater than 1. If the frequency is equals to 1, then I'm not going to append the frequency, I'm just going to write the number as it is, right? Now my problem says that I have been given an integer k. I can remove at most k characters from the original string, and I have to remove it in such a way such that the length of the final string that I got after encoding is as minimum as possible, and I have to return this length of the minimum string, right? So although the problem is very simple, it's just an application of take or no take DP, which we generally do in an AppSec kind of problem. So the idea is take or no take, but how to implement it is quite complex, and it took me some while to determine what should be the ideal implementation. So please bear with me on this part because we are going to have a 4-state DP, Ij. Let me define as P, Q, R and S, right? So what are these P, Q, R and S? This is a 4-dimensional DP. First of all, P is denoting, let's say, denoting the current index. So current index in the string, right? My Q is going to denote number of deletions left, and R is going to denote the last character taken, and S is going to denote the uh, count of the last character taken, right? So my DP of P, Q, R and S is going to denote the answer for the string if I am starting from position. So let me just write it in the line, position P, and let me just write it with comma. I am starting with position P and Q deletions are left, and the last character was R, and the frequency of the last character was S. So this is quite a complex DP state, I would say, but if you understand it, then this problem is very simple. So I'm just going to reiterate this what I have just said. I have 4 states. So DP of PQRS is going to denote the answer for the current state if the string starting from position P, right? So if the string started from position P, there were Q deletions left. That means I can delete Q more characters. The last character, the previous character in this string was R, and its frequency was S, right? So these are the 4 different conditions that I have for the current state DP of PQRS, right? So let me just write my helper function. My helper function is like int helper. I'm going to receive 4 parameters, int p, int q, int r and int s, right? So first of all, if p is equals to s dot size, basically if I have exhausted the whole string, if p is equals to s dot size, then the size after encoding should be equals to 0, right? If I have exhausted the whole string, the string or the encoded string will also be of 0 length. That is why I return 0 from here. If dp of p, q, r and s is not equals to -1, I'm just going to return dp of P, Q, R and S, right. So this is also very simple. Now we come on to the actual part where you have to define the transitions. So as I just said that this is going to be a classic example of take or no take PP, just a little bit complex one. So take or no take is equals to, let's say, infinity. We initialize both of them with infinity. If Q is greater than 0, that means I can decide to remove the current variable. That in that particular case, I am going to define my no take as P is going to get incremented by 1 because I am going to move to the next position. I am going to decrement the value of Q by 1 because I have made one deletion. Now if I delete the current character, the last character is not going to change and its frequency is not going to change as well, right. So this is how this particular part works. I am passing the P plus 1 string and Q minus 1 because I have deleted one more character. The last character is not going to change because I am deleting the current character, and my S is also not going to change, which was the frequency of the last character, right. Now if I decide to take the current character, there are again two cases. If let's say the string and its current position is equals to the last character, so I am just going to decrement A from it, is equals to the last character, that is P, right. So this is the case when I am deciding to keep the current character and the current character is equals to the previous character, right. So in this particular case, take is going to be helper of P plus 1, and then Q is not going to get affected because I am not deleting the current character. My previous character for the next position will be string of P minus A, and my frequency is going to get incremented by 1, right. Now in the other case, what I am going to do is take is equals to helper of, if the characters are not same, P plus 1 is still going to be the same, we are not deleting the current character, so Q is going to be the same. The character will be updated by the current position since we are not deleting the current character. But since this is a new character that I am taking and this character is not equal to the previous character, the frequency will reinitialize from 1, right. So now whenever I inserted a new character, what was the effect on the answer? So that what I am trying to say is, let's say this is AA and its encoded part was A3, right. As soon as I insert a B, right, so what happens to the encoded string? A new character is inserted. Whenever the previous character is not the same, a new character is inserted, right. So that is why I do plus 1 here, right. So I do plus 1 here. Now you might say that we did not do anything in this particular case when the current character is equal to the previous character. But yes, we will have to do something. We are going to define an increment. So please bear with me for a while more because we are just near to the solution. We are going to define an increment. So this will be equals to, let's say the previous frequency was 1, or the previous frequency was 9, or the previous frequency was let's say 99. So I believe I have covered all the cases. So I am going to define my increment like this, and I am just going to add the value of increment here. So let me just write plus increment, right. So did you just see what just happened? I am saying that in this particular case, when I want to keep the current character, right, and this current character is equals to the previous character, so this should actually be equals to R because R is defining the previous character, right. It is actually equals to the previous character. In that particular case, I say whether if there was one element or not, right. If there was only previously one element and I add one more element to its encoding is A, this encoding is A2. So I have added one more character to it. That means this particular case when the previous count was only equals to 1. Now let us consider that we had 3 A's. Its encoding is A3. Even if I add one more A, its encoding will be A4 and the answer will not change. But let's say we have A 9 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have these 9 times again and then add one more A. Its encoding was A9, its encoding is A10. So this is this particular condition when the current character is same as the previous character. I want to take the current character and the previous frequency was 9. As soon as I add one more character to it, my final answer will get incremented by 1 because now there is a new character in the final encoding. Earlier it was A9, now it is A10 where there are 2 characters after A, right. Similarly, for S99, we would have A99 here, and then if I add one more character, it will be A100, right? So in these three cases, I am going to increment my answer by 1, right? So this was all about this particular problem. At the end, I can just return my dp of p, q, r, and s as minimum of take comma no take, right? So let me just again discuss this part, this memorization function for the last time. So we have this helper function. Now you see the code is very small for this particular problem. You see we have the helper function, we have this dp state pqrs, where I define the state as it is going to store the answer if I am starting the string from position p, q deletions are left, the last character that was taken was r, and the frequency was s of the last character taken. Now if p is equals to s dot size, that means I have exhausted the string, and if I have exhausted the string, its encoding will also have 0 characters, that is why I return 0. Now if it is not equals to -1, that means I have already calculated it, that is why I am going to return dp of pqrs directly. Now I have initialized two variables, take and take, both are initialized to infinity. If q is greater than 0, that means I can make more deletions as well. I am going to define no take as helper of p plus 1, this is because I am moving on to the next position. Q minus 1, this is because I am making one more deletion, so the number of deletions left will be decremented by 1. And if I delete the current character, the last character and its frequency is going to remain the same for the next character. So basically if I had A here, then I have B here, and I have C here. So whatever is previous for this particular character is now going to be the previous for this particular character if I remove this one, middle one, right? So that is exactly what is happening. This R and S is not going to change. Now if I decide to keep the current character, I have two conditions: if the current character is equal to the previous character or not. If it is equal, then I am going to define my p as p plus 1 because I am moving on to the next position. Q is the same because it is not getting deleted. This character is getting updated because this character is included now. So this is going to be the previous for the next one, right? Now s is going to get incremented by 1, which was the previous frequency. So I am just adding one more character to the previous frequency, that is why I am incrementing s by 1. Now I have this increment factor as well. So whenever the previous frequency was either equals to 1 or equals to 9 or equals to 99, I am going to increment it by 1, right? Why is this so? Because if it was 1, it is going to become 2 and I'll have to add a new character at the end. If it was 9, I would have to change A9 to A10 and one more character will be added. So in each of these three cases, one more character will be added, and that is determined by INC, that is increment. If the previous and the current character are not same, I am going to move on to the next position, p plus 1. Q is going to remain the same, and str of p minus a, this is going to be the previous character for the next position, and my frequency is going to be 1. Why frequency is going to be 1? Because this is a new character and it does not match the previous character. Now in this particular case, I have to definitely append a 1. Why? Because let's say a was there, then I include a b. So for these three it was A3, but as soon as I include this particular B, I am going to write A3B, right? So these are all the cases covered, and I can just directly return dp of pqrs as minimum of take comma no take, right? So this was the whole solution of this problem, and I believe this is the simplest approach of this particular problem. Other approach might be a little bit confusing. This is simple because you don't actually have to write much inside this helper function. You see, I didn't even get the time to convert this memorization approach into iterative approach, but I believe you can take some time and do it, right? So this was not actually required, this string I was using in my previous approach. So as you can see the code, I've initialized my dp with a global array. This is a global array because dp of this size is not allowed inside functions. We can create it globally. If you create it inside this particular function, you will get runtime error, right? So I have these four set. This is for the size of the string, this is for the number of characters left, so this is also equals to the size of the string. Why? Because you can delete all the characters, the value of k can be up to n as well. This is for the 27 characters, there are actually 26. Why I have made it 27, I'll tell you in a while. And this is for the frequency. So if the size is n, the frequency can also be n, that is why I have taken 110 on all of these. The size is actually 100, I have just taken 110 to avoid any issues. So I have initialized the size with s dot size plus 1, and this for loops are just for setting all the values to -1, right? There is nothing else in it. Right. Now I return at the end helper of 0 because I will be starting at position 0, k because I have k deletions left. This is 26, because let's say from A to Z, A, B up to Z, these are 0, 1 and this is last 25. So for the first character, it is the starting character, I want to make sure that its previous character is something that can never be present in the string, right. So that is why I take it to be 26, because this will never be a part of the string and it will never match the first character, right. So you can take it up to the A to Z are up to 25, that is why I have taken 26 here, so that it does not match the first character, right. And I have 0 here because its frequency is 0 obviously. Now this is the base case. When current position is equals to S of sides, I return 0. If the current DP has been evaluated and it is not equal to -1, I am going to return it. Here I have used better variables. I have used a variable current position, and then I have left k, and then I have last character and then last count, right. Now I have initialized take and no take, both initialized with infinity. These are the three conditions of increment, that is last count is equals to 1 or last count is equals to 9 or last count is equals to 99, right. Now this is the taking part where I decide to take the current character. If my current character is equal to the previous character, then I move on to the next index, left k remains the same, the current character is updated and last count is incremented by 1 and I add increment to it, which depends on these three conditions, right. Otherwise, if the last character and the current character are not same, this part is exactly the similar. I take the same character and the frequency is 1 and I add 1 at the end. This is the only difference, this last part, where the frequency is initialized to 1 and I add 1 directly. Now if left k is greater than 0, that means I can make some deletions. I try to delete the current character by taking no take. Help, this current position will increment. This left k will get decremented by 1 because I am deleting the current character. Last character is going to be the same. Now it is not going to change. Why? Because if I have deleted the middle element, all the things that were previous to the current element will be previous to the next element as well. So last character remains the same and last count remains the same. At the end, I can return the DP of the current state as minimum of take comma no take, and this is my final solution. So let me just quickly submit this and show you that this particular code works. So why am I not signed in? I'm not sure. So just a moment. I'm just going to quickly sign in and submit this code. It says sign in. So you see this is also accepted. I'm just running it once again. You see this is accepted as well, and this solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.